Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. This is a recorded lecture for the chapter 6 Markov process. The objective of this chapter, the Markov process, is we want to write the transition matrices for Markov chain problems. Then we want to find the long-term trend for a regular Markov. And what is actually Markov chain or process? It is actually to study the stochastic processes, experiments in which the outcome of events depend on the previous outcomes. So this is a stochastic, unforeseen event. Okay? So we want to find the probability of the event to happen on the next outcome. Okay, referred to the previous one. We will look at the first example here. So this is example one. It said that a small town is served by two telephone companies, Mama Bell and Papa Bell. Then they have sales. Each month, 40% of Mama Bell customers switch to Papa Bell. And then there is the other 60% stay with Mama Bells. On the other hand, 30% of the Papa Bell customers switch to Mama Bells. So the above informations can be expressed in a matrix which lists the probabilities of going from one state into another state. So if you can see here, we have two companies, Mama Bells, okay, and Papa Bells. Bells and Papa Bell. Okay, due to each month. So each month, okay, each month. So we have two companies from Mama Bell and Papa Bell. And then the next month, the customer maybe will switch to another company. Let's say the first month, the customer go to Mama Bell. And then the second month, they can go to Mama Bell or they can actually switch to another company, which is Papa Bell. So the value in the matrix here referred to the informations given. Okay, so if you can see here, each month 40% of Mama Bell customers switch to Papa Bell. So you can see that from this matrix, where is it? From this matrix, okay, 40% from Mama Bell, okay, switch to Papa Bell. So that's mean 40% is equal to 0.4. So we know that the total probability must be equal to 1. Okay, so for every row, okay, for every row, the summations of the probability must be equal to 1. So let's say we have 0.4 here. That's mean on the other matrix column here, it should be 1 minus 0.4. So this is 0.6. Okay, and then another information is say that on the other hand, 30% of the Papa Bell customers switch to Mama Bell. So that's mean here from Papa Bell, they switch to the Mama Bell company about 30%. So 30% means 0.3. Okay, so we have 0.3 here, and then what is the value here? Why is get 0.7? So it is because the summation of probability must be equal to 1. So 1 minus 0.3, you get 0.7 here. So please, you need to know how to develop the transition metric for the problems. Okay, so this is the example of the transition matrix. Okay, so a transition matrix is always a square matrix because all possible states must have both row and column. So it's a square matrix. That means 2 by 2, 3 by 3, 4 by 4, 5 by 5. So that is what is meant by square matrix. The number of row must be equal to the number of column. All entries in the transition matrix are non-negative as they represent probabilities. So the value in the matrices cannot be negative because probability is only for positive value. Furthermore, since all possible outcomes are considered in the Markov process, the sum of the row entry is always equal to 1. This is what I mean. Okay, so if the question gives you only one value for each row, you actually can find another value by minus the given value with 1. 1 minus 0 0.6, 0 0.4. 1 minus 0 0.7, you get 0 0.3. Okay? So we see example 2 here. So what is the problems related to Markov process? What is actually we want to see? So we want to see the probability of the occurrence, okay, for the next event. For example, in this example, okay, we want to see the probability the customer from Mama Bell will switch to Papa Bell for the next 2 months. Okay, for the next 3 months, for the next 4 months. Because the initial transition matrix, they only provide you the transition from the first month up to the next month. And then we can actually find the probability from first month to the next 2 months, to the next 3 months, to the next 4 months. So that is what we want to solve in the Markov process. Okay, so we will look at example 2 here. So Professor Hay has breakfast at uh, Hoggies every morning. He either orders an egg scramble or a tofu scramble. So we have only two possible states. State 1 is egg scramble. State 2 is tofu scramble. So it's denoted as E and T. He never ordered eggs on 2 consecutive days. So what is meant by 2 consecutive days? 2 hari berturut-turut. Okay, 2 consecutive days. So for example, if the first day he ordered egg, so he will not order egg on the next day. So that means that probability is equal to 0. But if he does order tofu one day, on the first day, the next day he can order tofu or egg with equal probabilities. So equal probability, you have 2 events. Okay, so that means one, the total probability is equal to 1. So we divide by 2. So each event has 1/2 probability of occurrence. Okay, for the tofu. So egg here, you see, for A, they ask you to write a transition matrix for these problems. So we have egg and tofu, egg and tofu. So we have 2 by 2 matrices. Matrix. Okay, so egg, the first day, the professor eat egg. So the second day, he will not eat eggs for the 2 consecutive days. So that's why it's equal to 0 here. He never order eggs on 2 consecutive days. So he will not eat egg on 2 days consecutive berturut-turut. Okay, so egg on the first day, so tofu on the next day. So it cannot be egg and egg. So because this is 0, so like I said, okay, like I say, for row, the total of probability must be equal to 1. So 1 minus 0, you get 1 here. Okay, now we look at the state 2, when the professor eat tofu on the first day. So on the next day, if he eat 8, so the probability is 1/2. Also, on the second day, the probability is 1/2. Okay, equal probability. So that's why you get this transition matrix for this problem. So now it's come to the questions related to the matrix. So if Professor Hay has tofu on the first day, what is the probability he will have tofu on the second day? So it's directly come from this matrices. Matrix. Okay. So tofu first day, the tofu on the second day. Okay. So that's mean this is equal to 1 over 2. So that is the answer. And C. If Professor Hay has tofu on the first day, what is the probability he will have tofu on the third day? What is the probability he has tofu on the third day? So, in the present matrix just now, okay, here, so this is for first day and second day. So, you don't have the matrix for the third day. So you actually need to have a matrices for the third day. Okay, for example, we have here E, T, E, T. So this is the same lah. This is for the first day. And then this is for the third day. So how can we get the probability in the matrix here? So this is for the second day. This is for the first day. Okay, so now we cannot answer C because we still don't have the matrix. Okay, we still don't have the matrix from the first day to the third day. So how can we get the probability for this matrix? Is by using the formulations of Markov process. So how? This is about the formulations of the Markov. We know that we let T is equal to the first transition matrix just now, 0, 1 over 2, 1, 1 over 2. So to get the matrix on the third day, so you need to square the transition matrix. Okay, you need to square the transition matrix. Okay, because it's happened on the second time. Okay, second time means that we need to square the matrix of the first transitions. So this is the matrix calculations. So you square the T, so you have 0, 1 over 2, 1, 1 over 2 times another matrix of T. So matrix of T times matrix of T. So this is basic matrix multiplications. So it's row divided by column, row divided by column. Okay. So for example, first row times first column. So 0 times 0. Okay. 0 times 0 plus 1 times 1 over 2. Then you get this one. Okay. Again, 0, first column, first row, second column is for this part. 0 times 1 plus 1 times 1 over 2. So you get this. So this is the matrix for the first day to third day. Okay, so that's when you get the matrix of this, you can answer the problems. So if Professor Hay has tofu on the first day, what is the probability he will have tofu on the third day? So first day he eat tofu. Okay, so the third day he also eat tofu. So what is the probability? So the answer come from this matrix. So you can see that the answer for this is 3 over 4. Okay, and then the another questions D. Sorry, so this is Again, D. If Professor Hay has tofu on the first day, what is the probability he will eat on the third day? So you will use the same matrix here, first and third day. So tofu, he eat 8, so 1/4. Okay, right now, so if Professor Hay has egg on the first day, what is the probability he will have tofu on the fourth day? So on the fourth day, so you need to have another matrix, okay, from first day to fourth day. So previously you already did the matrix for first day and the third day. So again, it's a repeated process, okay? So because first day to second day, sorry, this is first day to second day. This is first day to third day. Another one is first day to fourth day. So you will have 3 transitions. So that's mean we need to cube the t. Okay? Power of 3 here. So the power of 3, t times t times t. So we already get t power of 2 from before. So we just need to time with another t, okay, to get the 3t cube. Okay, so again, this is a basic calculation of matrices. So I believe you already can solve the matrix problems. Okay, so we calculate the matrix and then we get this matrix transition for first day and fourth day. Okay, so we can answer the questions. If Professor Hay has egg on the first day, so what is the probability he eat tofu on the fourth day? So directly the answer come from the matrix here. So the answer would be 3/4. Okay, so that's how we solve problems regarding the Markov chains. Okay, so now I will teach you how actually we can solve matrices here. Okay, from calculator. How can we get the answer directly from the calculator? Okay, so you can use what Casio FX570. So you can see that we have shift, we have matrix here at above number 4. So you click shift, sorry, I need to clear this. Okay, so shift, no, cannot. You need to press mode, okay, find mode for matrix, saying matrix. So in this case, matrix is number 6. So it's depend on your calculator, okay, it's depend on your calculator what is the matrix referred to. So we need to key in, okay, the matrix. So right now we have matrix. For example, we want to key in T here. So let's say T is matrix A. Okay, so this matrix T is 2 times 2 matrix. So we choose 5. So we key in the value that we get from the T, 0, 1, 1/2, 1/2. Okay, now we want to multiply T by T, T times T, okay, T squared. So it's metric A times metric A. So how can we call back the input that we do? Okay, so we already do the mode under the matrix. So you can see above your screen, they have MAT. So we are right now in the matrix form. Okay, so you can use the matrix above 4 here. So we already key in the A just now. So it's already in the calculator. So we want to call back A. So we shift matrix. Okay. So matrix A referred to number 3. So we click 3. Okay. Matrix A we call back times with matrix A. T times T. So matrix A times matrix A. So shift matrix shift 4 Matrix A is 3. Okay, so we press equal sign. So you can see the answer. Okay, they give you the answer in the decimal number. Okay, but you actually can play with that. So this is can be, so this you get the same answer as what I get from this one, this part. Okay, I get from that the same answer from the calculator. So it avoid the careless mistake when you do manually calculation here. Okay, so this is another way, okay, using your calculator to solve the matrix. So we get the answer for this using calculator. And then the another one, this one also again is t times t times t. So that's mean is metric A times metric A times metric A. So you can actually call back metric A times metric A times metric A. Then you get the answer exactly the same as what I got here. 0.25 is 1 over 4, 0.75 is 3 over 4, and so on. Okay, so it's easy, right? Using your calculator. So please, to avoid careless mistake, try to solve using calculator for the matrix problems. Okay, so done this example. So let's try to do this. Okay, Professor Simon either walks to school or he rides his bicycle. So we have to state whether he walk or he ride. Okay, he walk or he ride. If he walk to school one day, then the next day he will walk or cycle with equal probability. Okay? But if he bicycle one day, then the probability that he will walk the next day is 1 over 4. So A express this information in a transition matrix. So assume that the first day is Monday. So we have to do the transition matrix of, we have to stick work, ride bicycle, walk, ride bicycle. Okay, so this is Monday. Because the problem is on the next day. So Monday, the next one is Tuesday. Okay, so if he walk to school one day, then the next day he will walk or cycle with equal probability. So one day he walk on the first day he walk, so that's mean the probability is equal 1 over 2, 1 over 2. Okay, and then if he ride a bicycle one day, then the probability that he will walk the next day is 1 over 4. So this is 1 over 4. So what is the value here? How can we get the value here? So rho summations of probability is equal to 1. So 1 minus 1 over 4 is 3 over, get 3 over 4 here. 3 over 4. Okay, so that is for A. And then write metric that give probability of a transition from Monday to Wednesday. So B, okay, B, we need to have another matrix. Okay. So let's say this is walk. This is right. This is walk. This is right. So this is Monday. This is Wednesday. So transitions. Monday to Tuesday to Monday to Wednesday. 2 times transition happen. So again, how can we get the matrix for the Monday to Wednesday? So it's actually, so we let T equal, let's say we let A lah. We let A equal to the matrix 1 over 2. 1 over 2, 1 over 4, 3 over 4. Okay, so to answer B, you need to square, okay, you need to times your matrix A by A. So to get this one, so it's actually A times A. So again, I will not show you the manual calculations. So I directly show you the answer using the calculator. So it should be times with the, let's say this is A square. So it's times with A 1 over 4, 3 over 4. Okay, so we need to input the value in your calculator. So make sure it's on the mode matrix. So again, matrix. So key in matrix A again or B, it doesn't matter. Okay, so let's say we key in A. So it's matrix 2 by 2. So you just key in the value 1 over 2, 1 over 2, 1 over 4, 3 over 4. Okay, now we need to square the A. So shift 4 matrix A times shift 4 matrix A. Okay, so this is equal sign. So this is, you get the answer for this is 3 over 8. 3 over 8. Again, 5 over 8. 5 over 16. 11 over 16. So that is the answer for B. So you can answer C and D from this matrix. So what is the probability? Simon will ride bicycle on Wednesday if he walk on Monday. So Monday he ride bicycle on Wednesday. So the probability is 5 over 8. What is the probability Simon walk on Wednesday if he ride his bicycle on Monday? So ride bicycle, walk on Wednesday. So it's 5 over 16. Okay, write the transition matrix from Monday to Thursday. So that's mean you need to have A power of 3. So A times A times A. So I leave it to you to answer this. So that's how we solve the problems. Okay. So we go to the next one. Go to the next one. So we go to the next one. There is a steady state probabilities. Okay. So as we continue the Markov process, we find that the probability of the system being in a particular state after a large number of periods is independent of the beginning state of the system. So long run, as the time approach infinity, a Markov chain may settle down and exhibit steady state behavior. So let's say you repeatedly want to find a power of 5, a power of 6, a power of 10, a power of 12, or a power of 20. It comes at the ends, the probability becomes steady. Okay, steady state. So when there is steady state, so you will have these formulations. So this is our transition probability that we did just now. Okay, so this is the steady state probability. Pi 1, pi 2, and then this is formulation. Okay, so if the question asks you about the long run, about the steady state, you need to use this equation to get the value of pi 1, what is the value, and then pi 2, what is the value. Okay, so that is steady state probabilities. So we will look at this example. The management of the new fungal soft drink company in Southampton believe that the probability of a customer purchasing the red pot or the company's major competition, Super Cola, is based on the customer most recent purchase. Suppose that the following transition probability are appropriate. So from this is the drinks, okay? From red pot to Super Cola, red pot to Super Cola. So this is the transition matrix. What is the probability that the customer purchase red pop on the second purchase for a second period of time? Okay. So this is the first period of time. From red pop to red pop. This is the first period of time. Red pot to red pot. Okay. So the second purchase is you purchase another time. So we have two transition here happen. So that is meant by the second period of time. So that means we need to have another matrix. Okay, another matrix. So let's say this transition refer to A, matrix A. Transition matrix here refer to A. So we need to find the A square. Okay, because it happened two times. So need to find A square again using your calculator to get the A square. What is your A square? So it's 0.9 matrix A 0.9, 0.1, 0.1, 0.9 square. So calculator, call your calculator. Okay, mode matrix. So matrix A lagi is 2 by 2, 0.9, 0.1, 0.1, 0.9. Okay. So shift mat. Oh no, we need to clear this. So AAC, shift matrix, call matrix A times shift matrix A. So it's equal to 0.82, 0.18, 0.18, 0.12. Okay, we get this answer from the calculator. Okay. So what is the long run market share for each of these two products? So when it say long run, so you need to use this equation. So you need to have pi 1, pi 2 equal to matrix of pi 1, pi 2 times with A, matrix A just now. And then we have pi 1 plus pi 2 equal to 1. Okay, so we solve this problem. Okay, so we have this equation. Okay, so we need to times. Okay, it's this is row. Okay, row 1 times 2. 1, if you remember, matrix 1 times by 2, okay, times matrix 2 by 2. So the answer can be would be in matrix. Cancel out the middle one, so it's matrix 1 by 2. So the answer will have row 1 only and 2 column. So you can get that from this one lah. You can get matrix 1 and 2 from this kind as multiplications. Okay, so again, row times column. So pi 1 times 0.9 plus pi 2 times 0.1. And then next one, pi 1 times 0.1 plus pi 2 times 0.9. So you get this answer. So we cannot find the value for pi 1 and pi 2 yet. Okay, so we from this one, okay, so this matrix equal to this matrix. Pi 1 is equal to 0.9 pi 1 plus 0.1 pi 2. So that is our first equation. We need to keluarkan, move, okay, the matrix outside. Okay, and then another one is our pi 2 here. So pi 2 equal to this matrix, 0.1 pi 1 plus 0.9 pi 2. Okay, so we have two equations, and then the additional equation, the last one would be this one. Pi 1 plus pi 2 is equal to 1. Okay, so that is our third equation. So we need to solve this problem to get the value of pi 1 and pi 2. So here I solve 3 first. So I make sure pi 1 is only the variable on the left side, and then the other variable will move to the right side. So I get this. So when I get this, I can actually substitute into any of these equations to get the value of pi 2. So I substitute into this equation of pi 2. So pi 1, I substitute into this pi 1. Okay, substitute into the pi 1. So I got pi 2 is 0.1 times pi 1. So our pi 1 is 1 minus pi 2. Okay, so substitute in here plus 0.9 pi 2. Okay, so solve this problem. You times if the bracket, expand the bracket, and then you get pi 2 and pi 2. Okay, so pi 2 move to the left side. All of the pi 2 move to the left side. So pi 2 plus 0.1 minus 0.9. Okay, and then you get 0.2 pi 2 is 0.1. Pi 2 is 0.1 divided by 0.2 is 0.5. Okay, so we know that since the pi 1 plus pi 2 is equal to 1, so when pi 2 is 0.5, so pi 1 is 0.5. So that is the answer for B. What is the long run market for each of these products? Okay. So if the population in Southampton is 5770 people, compute the projected number that we purchase in the long run. So in the long run, so we will use the value of pi 1 and pi 2. So the answer for C, okay, is just time the value of people here with the pi 1, sorry, 56770, you need to time with pi 1, 56770, you need to time with pi 2. So this is the answer for C. So what compute the projected number of people that will purchase on the long run. So this is the projected number of people that will buy Red Pop. This is the projected number of people that will buy Super Cola. So they are the same because when we calculate pi 1 and pi 2, the answer is 0.5 for both. Okay, so that's why we get the same answer. Okay, so that is first example of steady state. Okay, so we will look at another example of steady state here. What is the probability that a customer from Super Pet will visit Global on the second week? Okay, so a pet station owner is considered of has opened just down the road. Okay, analysis over the last week has indicated the following probabilities for customer switching the station they stop at each week. So on the second week, okay, so this is on the first week or first quarter, they change. Okay, each week. So this referred to the transformations of probability each week. So this is considered as the first week. Okay, so right now we need to calculate, okay, the probability for the second week. So again, we need to let the transition equal to A, for example, 0.75, 0.25, 0.55, 0.45. So this is for the first week transitions. So we need to calculate the transition on the second week. So that is for A squared. Okay, second week or second quarter or second year. Okay, so that refer to A squared. So A squared is equal to, substitute into your calculator just now. It's still matrix. So mode 6 matrix 1, 2 times 2. So it's 5. So 0.75, 0.25, 0.55, 0.45. So we times matrix A with matrix A squared. Okay, so you get the answer 0.7, 0.3, 0.66, 0.34. Okay, so what is the probability a customer from Super Pet here will visit the Global on the second week? So the answer would be 0.3. Okay, so that is how we solve the problem. So what would be the long run predictions? So the long run is you need to find the pi 1 and pi 2. So when it's a pi 1 long run, truth, you just need to do another formulations. Pi 1, pi 2 is equal to pi 1, pi 2 time with A. 0.75, 0.25, 0.55, 0.45. Okay, so that is the solutions to this. Wait, copy this first. Oh, no, 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 no. Wait. Yeah. Okay, so we need to solve these problems. Okay, so this is 0.75, 0.25, 0.55, 0.45. Okay, you need to calculate. Okay. So 0.75 times pi 1 plus 0.55. And then row by column 0.25 times pi 1 plus 0.45. Okay, now we have to find the first equation. Okay, move. Okay, need to keluarkan. Okay, we need to have pi 1 here equal to the first column and first row here, 0.75, 0.55. And then another one is part. Pi 2 is for this equal to this one. So pi 2 is 0.25 plus 0.45. This is 0.4. And then the last equation would be pi 1 plus pi 2 equal to 1. Okay, so I leave it to you, okay, to solve this equation, which is equation 3. Let's say you want to have pi 2 on the left side, so pi 2 is equal to 1 minus pi 1. So substitute the pi 2 into any of equation 1 and 2 or 2, so you get the answer for pi 1. Okay. Also, you can change this to the leave pi 1 on the left side. So pi 1 is equal to 1 minus pi 2. Substitute pi 1 into the equations. Okay. So you get, substitute pi 1 into the equation of 2 here. So you get the answer for pi 2. So then pi 2, substitute here, you get the answer for pi 1. Okay. The summation of pi 1 plus pi 2 must equal to 1. So please do it by yourself and check whether you get the same answer as the given one here. Okay, and then we have another example. So it give you the value here. So they want to project the number of people in the long run. So that means you need to use the steady state formulations again. So I will leave it to you to solve these problems. Okay, so that's end of this chapter. So please, if you don't understand, try to text me. Okay. So I hope that you will understood everything here. So that's all from me. Thank you.